Welcome to CIDR Notation. And CIDR Notation basically stands for Classless Interdomain Routing Notation. And what we have here is an IP4 address. An IP4 address has 32 bits, and they're broken down into four parts. And each part has they're basically broken down into four parts. Every IP4 address has a 32-bit value, and they're broken down into 8-bit chunks. As you can see, one, two, three, four, five, 6, 7, 8. And it's the same thing all the way down. So silent notation basically changes, for example, let me show you something. It changes this one, 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 one. Let's see. One, two, three, four, five, 6, 7, 8. It changes ones into a human readable format. So let me go ahead and get rid of this. Let me go ahead and get rid of this so I can further explain. Cider notations are written in a binary format. You might not see this when you're looking at an IP address, the 1, 2, 4, 8, 16, 32, 64, 128, but IP addresses are written in a binary format. So, for example, if there was a 1 right here, that 1 would activate this particular slot. Oh, that for example, if you see a 1 right here, this 1 will activate this binary value. And if there was a 1 right here, this 1 will activate this binary value. Just to put this in a human readable format, let me show you exactly what's going on here. So, because this value is activated because there's a 1 right here, you can just go ahead and write down 64. You see another 1 right here. So this 1 activates this binary value. So you can write 1 right here. And remember, it's still a dot right here. What you'll be doing is adding the binary value to come up with the IP address. So to figure out the IP address, let me show you here. So 64 plus 1 is 65. So far you have 64 dot. Let's move on to the next section. Let's say, for example, give me 1 second. Let's say, for example, there was a 1 right here and a 1 right here. And remember that the 1 activates the binary value that is on top. You won't see this 1, 2, 4, 8, 16, 32, and 64 and 128 if you're looking at an IP address, but it is there. So this one activates this 16, so you can go ahead and write 16. And this 1 activates this 1. So remember, you add them up. 16 plus 1 is 17. All right. So because there are only 2 slots activated in this particular portion of the IP address, you have 17 here, and you can just move on to the next slot. Remember, we could just do it like this so you know exactly what's going on. 'Cause I know this can get a little confusing. All right. Now we're moving on to the next section. Sorry about that. Let me zoom out a little bit. Same thing with this section over here. Let's say there was only a 1 right here and nothing else. Let's just say there's just 1 right here and nothing else activated. So for this particular section right here, the number will be 128. And the reason being is because the 128 slot is activated. So you write down 128. And there are no other slots activated. As you can see, there's a 0 here, 0 here, 0 here, 0 here, 0 here, and 0 here, 0 here. Meaning that there are no other slots activated. So this section will be 128. And because there are no other numbers to add, you'll be moving on to the next section. Alright, we can zoom out right here. Right. Same thing for this last section right here. Let's say there was a 1 activated in this slot. Maybe we'll do another one right here just to switch it up a little bit. All right. So because there are no other zeros there, because there are no other ones, because there are no other ones activated besides these two, all you have to do is bring these value down. So you have 8 right here because this slot is activated, and the reason why it's activated is because you see this 1 right here, and the next slot that you see activated is this because there's a 1 right here. So you'll bring that down, and remember, you'll be adding the number. 8 plus 1 is 9. So your IP address is this. Let me actually delete. Okay, let me just delete everything so it's not confusing. Okay. All right. So this is the IP address in a human readable format. So it is 64, 17, 128, and let me not forget, .9. This is the IP address. All right. Next, we'll be working on slash notations. And what slash notations are, it's just a way of not having to write 255, 255, 255. And let me just, instead of writing 255, 255, and 255, every time you write an IP address, you can just write 64 dot 17 dot 128 dot 9 slash 24. And the reason why this is 24 here as a slash notation is because remember, each one of these each one of these portions has 8 bits. So 1, 2, 3, 4, 5, 6, 7, 8. First bit. Same thing with the next slot. 1, 2, 3, 4, 5, 6, 7, 8. 8. Same thing with the next slot. Each one of these has 8. And because there are 255s here, 255, that activates this. It activates this bit. 255 activates this bit, so which is 8. 255 activates this. And when you add them together, you'll get 24. So this 24 right here in slash notation is basically saying that there are 3 sections activated, if you want to put it in a simple way. And the reason why they are activated is because its subnet mask is basically saying that they're activated because of the 255. Now, if there was just, give me a second, let me just delete this. Oops. All right, let me delete this as well. Let me delete this. All right, just take a second and try this out for yourself. Remember, each portion has 8 bits. 8, 8, 8, 8. And if you see a 255, that means that particular bit is activated. So try this out for yourself and figure out what the slash notation will be for this example right here. All right. If you're all done, you can press play. All right. So in this example right here, because the 255 activates this section, you have 8 bits that were activated because the 255 is here on this subnet mask. This bit is activated. So the slash notation for this example will be 16. So this wraps it up for slash notation and CIDR notation. If you have any questions, feel free to comment down below and I can explain it further. But until then, see you next time. Thank you for watching.